So in the last video, we saw how we can compare numbers. So if I have two numbers, let's say x is 10, y is 6, I can do checks like if x is less than 10, if x is less than y, print x is smaller, else print x is larger. And so in this situation, x is greater than y because 10 is greater than 6, so I'm going to get the x is larger message. Now, can I compare text? So let's say I have cat and I have dog. And I check if cat is less than dog, and the answer is yes. So when I want to compare strings or characters, just a single character or a bunch of characters, basically think about a dictionary. If I was to go to a dictionary, which word would I find first? Would I find cat or dog? And because C comes before, so C comes before D, cat will be considered smaller. And here when I check, cat is smaller than dog, so I get x is smaller because x is less than y. So how is the comparison actually happening in the background? Well, every character is stored as binary, and I think we talked about that before. So if I look at the letter A, uppercase A, for example, it's stored as the number 65. This is how it's stored in binary, but this is hard for us to understand as human beings, so we convert it to our base 10 system. So we say A is 65. Here, C is 67, D is 68. So 67 is smaller than 68, and that is why C is considered smaller than D. And the nice thing about this is that it helps you do sort words, or you can do things in alphabetical order. The only tricky part is that notice that lowercase letters come later. So if I want to compare, let's say, cat and lowercase cat, you will find that they are not equal. So if I come here and let's do A is cat and B is lowercase cat, and I want to see which one is smaller. So I'll say if A is less than B, print uppercase is smaller than lowercase because A is uppercase, else print lower is smaller. And this line of code is not going to get executed. So here I find that uppercase is smaller. Why? Because A, which is cat, uppercase cat, is smaller because uppercase C is stored as 67. So this one, C is 67, while lowercase c is 99. So when we're doing comparison of words, we can do them using greater than and less than and all that. We just have to watch out for is that uppercase letters and lowercase letters are not the same. You can also do comparison of words. For example, I can say, let's say status. Someone's status was absent. Okay? I can say if status equal absent, print they were absent. Else print they were present. And so here, when I run this code, it'll say they were absent because I set the status to absent. So you can do also comparison like equal with strings. Now, if I change the status, let's change it to present. Now it's not going to match the equal absent. So it's going to go to the else statement and say they were present. So we can do comparisons using strings because strings are stored in binary. Okay. Now, if I want to compare floating point numbers, I want you to think about floating point numbers, decimal numbers, as non-precise numbers stored on the computer. So here I have A is equal to 0.0037 divided by 100, and B is 0.000037. Now, if you print A, you will find this huge number. If you print B, you'll find a similar number. It's just missing all these zeros. Now, there's a little 5 here that's you can find, and that's because floating numbers, when the way they're stored in binary, it's very hard to convert floating point numbers, decimal numbers, to binary and get like an exact 0 or 1. And so there's a little bit of estimation that happens. And because of that, you find that this number, when the division happened, it has this extra 5 after like a bunch of zeros. And because of this very small difference, these two numbers, when I compare, if A is equal to B, I find that they're not equal. Even though both of them, for us, if you gave it to someone to do by paper, in both of them, it would just be, 3.7 times 10 to the negative 5. And so the solution to this is, when you are comparing floating point numbers, is you want to do rounding. And there is a function called the round function, which takes a number and then comma, how many digits do you want to round to? And here I'm saying I want you to round to 5 digits. Okay, 5 digits of precision. And the reason we need 5 digits of precision is because we have a lot of zeros here. And so if I do that, then I will get that the numbers are equal, and I get the equal printed. So this is just something to keep track of. If you ever have to compare floating point numbers, you want to do the rounding. Now, what I want to talk about now is how to do more than one decision. So we started off by just showing, what if I want to do an error check? If the grade is less than 0, I want to issue some error. And then we said, well, how about if I want to do something if it's less than 0, and another thing when it's greater than 0? So we talked about the if-else. Sometimes you might have a nested decision. You might want to check something. So for example, here, the status, if the status was absent, so let's bring it back to absent, maybe I want to see why they were absent. So maybe I want to print a message, ask them. So let's use input excuse. Input, do you have an excuse? Okay. And if the user says yes, I'll print, okay, you're excused. And you wish life was that simple, right? Oops, and here we should use the double quotes because I have a single quote in the middle. Else, print 0, because it was unexcused absence. So here I have a nested if condition. I'm asking a question, checking their status, and based on their status, I want to check another condition. And you can have multiple nested conditions. So here, if the user was absent, oops, and I need double quotes here too. So let's use double quotes here. Again. So here it was absent, so it's asking the user if they have an excuse, and I have an excuse. I'm going to say yes, so it says, okay, you're excused. If I run it again and I say no, it says, sorry, it's a 0. So this is a nested if statement. Sometimes you might want to write code that has nested if statements. So let's look at this code here. We have x is 42, and I'm checking if x is greater than 1. So here, if x is greater than 1, it's going to go print a message. So it's printing a message, and then it's doing another check if x is less than 100. And so here I see in the flow chart the check for x is less than 100. If the answer is true, it's going to print less than 100. Otherwise, it does nothing. And all the way at the end, we have the all none. So this is a nested if. Sometimes it might be more complicated. Like when I'm doing your grade, I might come and I say, OK, will ask the user for their grade. I'm going to read it in and save it. And now if their grade, if the score the user entered is greater than or equal to the A score. So I've set my scale here that an A starts from 90, B is 80, C is 70, D is 60. And I ask if the grade, if the score they entered is greater than or equal to my A score is greater than 90, I'm going to say it's an A. Well, what if it's not greater than 90? Well, I need to do another check. So in my else, it's not greater than 90. So I need to go to the else. I'm going to check if it's greater than 80. If it's greater than 80, I'm going to say it's a B. Otherwise, I'm going to do another check and see if it's greater than 70. If it's greater than 70, it's a C. Otherwise, I need to go and check if it's greater than 60. If it's greater than 60, I'm going to say it's a D. Otherwise, it's an F. And so you see how here, like it's going in, the indentations are just starting. It's really hard to do that. And so what Python has and other programming languages also have is something called the if, elif, else. So elif is a short for else if. So basically here you're saying if x is less than 2, do something. Otherwise, do another check. So this is a combination of an else if. Otherwise, if x is less than 10, say medium. And then here I only have 3 cases, so I'll just say else print large. And so if I want to see how I can write the grade calculation code a little bit cleaner, I would use if, elif, like that. So if the grade is greater than 90, it's an A. Otherwise, if it's greater than 80, it's a B. Otherwise, if it's greater than 70, it's a C. Otherwise, greater than D, it's greater than 60, it's a D. Otherwise, it's an F. And so this is a lot neater than having nested expressions. So here, what I want us to do is write some code together. So assume that 2 variables, var A and var B, are assigned values of strings. So let's just go and create those 2 variables. Okay. So let's just say var A equal to, I don't know, Java, var B equal to Python. So here we've created just 2 random strings. Now, what does it want us to do? It says write a piece of code that compares the 2 variables, and don't look at the answer at the bottom. It says if var A is bigger than var B, print bigger. So we'll go and we'll say if var A is greater than var B, print bigger. And when you're reading, when you have a big assignment to do or a lot of code to write, sometimes it gets overwhelming reading the whole problem at once. So what I suggest you do is read the whole problem, get an idea of what it's trying to do, and then go back and read little by little. So here it's saying we have 2 variables. So let's create those variables. Then it has a check. It says if var A is bigger than var B, print bigger. Well, go and do that and write the code for that. So don't get overwhelmed with when you have a big assignment. Just take every little piece of text that they have described and convert that into code. So now it says if var A is smaller than var B, print smaller. So here we see that these are distinct. So either A is bigger, or A is smaller, or they are equal. So this is an example of an if, elif. So if they're bigger, if A is bigger, otherwise, if var A is smaller, and the last option is if they are equal. And so in this case, I don't have to put an elif. I don't have to put an elif var A equal to var B, because that's the only option that is left. If I did, it will give me the same answer. And so here, let's just comment out the code that's asking for an excuse. So let's look at it together. Java and Python, which comes first in the dictionary? J or P? So J comes first. So that means J is smaller. So that means var A is smaller. So I should probably get the print smaller printed. And I do. I get smaller printed. Now the next thing I want to talk about is creating variables that store Booleans. So just like you can create variables that store strings and variables that store numbers, you can also create variables that store true or false. So here, for example, I can say absent equal to true. And if absent, print A were absent. And notice here, because absent is a Boolean variable, it's storing a Boolean, when I come to use it in the if statement, it's already a Boolean. So here, this is already the word true or false. It's already a Boolean expression. And so I don't need to do anything else. So here it gives me they were absent because I set it to true. Now, if I set it to false, I would not get that printed. So if I say false, I'm not going to get that they were absent getting printed. It didn't get printed. Okay, so you can do it like that. Some people like to say if absent equal to true. They like to do that. But that's really redundant. You're just saying if a Boolean is equal to a Boolean. Okay, so you can do that, or, you know, you should just, if it's a Boolean expression, you can leave it like this. So you can use Boolean variables also. Now, the last thing I want to show you is checking for non-numbers. So when we were doing the grade, for example, in a last class, let's say the grade of a person, int, again, input, enter your grade, and let's just have if grade less than 60, and F and pass. So here, if the user enters, 90, it'll say pass. If they enter 44, it says F. But what if the user enters something that's not a number? Let's say they entered that they got 70. The program crashes. And it's telling me that it's crashing at line 46. So we want to always be able to read this. So here, when you say trace back and all that, it's complaining at my file on line 46. I'm going to go to line 46. This is the line that it's complaining about. And it's saying invalid literal for int with base 1070. So it's basically saying that you tried calling the int function, and you gave it 70 because that's what the user typed. And I can't convert 70 to a number. It's not an int. So how can I say, basically what I want to do is I want to say if the user entered something that's not a number. So there isn't really an easy way to do that. So how we're going to do it is using something called the try catch. And we're going to see that more in another chapter. We're going to get into more details about it. But basically, the try except. Python, it's try except. In Java, it's try catch. But in Python, try except. So what you do, the code that you're trying to convert the string to a number in, you put it in a try. So basically, you're telling the code, try doing this. You're telling the Python interpreter, try running this code. And if you run into any exception, into any problem, I want you to do what's under the except. So this is saying if this code cannot be run, go to the except and do what's under it. Okay, so how would I do that in my code? So basically, I want to try running this code and see if there's any problem. So what I do is I say try. And so I'm going to try running this. I'm going to just indent it all. And then I'll put an except, and I'll say print you entered an invalid grade. I'm telling the Python interpreter, just try doing this. And if you're good, great. Otherwise, so the except will only get run if a problem occurs. Okay. So if I run this code and I enter, a grade, 89, it's fine. But once I run it and I give it any string that cannot be converted to a number, it will kind of have an exception. There's an exception that's happening. So it failed to do that. So it will throw itself into the except. It will throw the code, the interpreter will go into the except and print you entered an invalid grade. Okay. And I might want to say must be numerical to make it a little bit clearer. So this is a way for you to catch problems in code that might happen if the user tries to enter something that is not a number. So for the classwork for this part for today's class, what I want you to do is use an if, elif, else statement. Basically, you're going to write a program that will calculate and display a person's body mass index. Okay, and the BMI is usually used to determine if someone is overweight or underweight. So what you're going to do, this is the formula to calculate BMI. It's 703 times the weight divided by the height squared. Okay, so height to the power 2. So you're going to ask the user to enter their weight in pounds. You're going to ask them to enter the height in inches. And now that you have the weight and height, you can calculate the BMI by using this formula. And I want you to make sure that it's formatted to 2 digits after the decimal when you're displaying it to the user. Now, after you display it, you want to tell them whether they're overweight or underweight. So if the BMI that you calculated is greater than 25, you're going to print overweight. If it's less than 18.5, you're going to print underweight. And if it's between 18.5 and 25, you're going to say optimal. Okay. Now, if the user at any point enters an invalid weight or an invalid height, like some gibberish or some text, you're going to tell them invalid value entered. Okay, you're going to test it on a HackerRank and submit your code with a screenshot of passing. And again, this is a summary of what we talked about in chapter 3. We talked about the if statement, the if else, and the if elif. We talked about the try except, and we talked about the relational operators and the logical operators.